Hello and welcome. We are discussing PYQs of number system and the theme was classification of number. We have already done few problems. Let's move on to the next case. So this is our next case. It says consider the following in respect of prime number P and composite number C. So the first thing that we need to know over here is what are prime numbers. Numbers that are divisible by only two different numbers, or the numbers that are having only two factors are called prime numbers. For example, 17. It is divisible by 1 and 17 only. So there are only two numbers in this nature that can divide 17 completely. So 17 is a prime number, right? The smallest prime number is 2. Then 3, 5, 7, 11 and so on. Now what are composite numbers? Numbers having at least three factors. For example, 6. 6 is divisible by 1, is divisible by 2, is divisible by 3, is divisible by 6. So 6 is what kind of number? 6 is composite number. Now next is the question says consider the following in respect of prime number P and composite number C. So P can be any prime number and C can be any composite number. So based upon that, we have to tell whether P plus C divided by P minus C can be even. Meaningly, we have to find out one such number P which is prime and one such number C which is composite, so that the result of this expression comes out to be equal to even. Now suppose your P is 17. 17 is prime number and your C composite number, let's say composite number is 15. Let's try to put these two values over here in statement number 1. So P plus C, 17 plus 15 divide by P minus C, 17 minus 15. So 17 plus 15 is 32. 17 minus 15 is 2. Answer is 16, which is an even number, right? So we found one such case that is in the line with the statement number 1. Hence, the statement number 1 is correct. Okay. Now, let's move on to the next statement. It says 2 when multiplied by prime number P and when added to composite number C, the result must be odd. So we have to assume one prime value for P and one composite value for C such that the result comes out to be equal to odd. Only one such case. So see, suppose your prime number P was 3 and your composite number was, let's say, 50. C is composite, so composite number, let's say 50. Now if we add them, 2 into 3 is 6 plus 15, which is 21. And what kind of number 21 is? It is odd. Hence we found one such case which is justifying this given expression. Hence statement 2 is also correct. Okay. Now the third statement, P C can be odd. P C can be odd, meaningly P into C is odd. So let's say P is 3, 3 is prime, and your composite number C is, let's say, 9. 9 is composite number because 9 is having how many factors? 3 factors, 1, 3 and 9. Okay. Now P into C, 3 into 9 is what? 27, and 27 is what kind of number? It is odd number. Hence we found one such case which is justifying the statement number 3 also. So the right choice over here should be option D, because in this question we were looking for which of the statements given above are correct. I hope class this is clear to everybody. Let's move on. Now, next case. Again, this question was there in CSAT 2022. It says, consider the following statements in respect of two natural number P. P is a natural number and Q is also a natural number, such that P is what? Prime, and Q is what? Composite. We already know the definition of prime number and the definition of composite number. So P can be equal to any prime number, such as 2, 3, 5, 7, 11, 13, and so on. And Q can be any composite number like 4, 6, 8, 9, 15, 18. Okay. Now, so based upon this statement, we have three statements more. P into Q can be odd. So it can be written over here. So we have to find out one such assumption which will justify this case. Okay. One such assumption which will justify this second case as well as this third case. And after that, which of the above statements are correct? So we have to find out of these three statements, which statement is correct. Okay. So let's try to justify the statement number 1. It says P into Q can be odd. So think about one such prime value for P. Let's say prime value of P is 3 and one composite value of Q. Let's say Q is 9, such that their multiplication comes out to be equal to an odd number. See, 3 into 9 is what? 27, and 27 is what kind of number? Odd number. Okay, so statement number 1 is absolutely correct. Now statement number 2, Q upon P can be prime. Q upon P can be prime. What kind of number Q is? Q is a composite number. So let's say we want Q upon P to be prime. So assume such value of Q and such value of P so that the result comes out to be equal to what? Prime. So let's say Q is 15 because it is written that Q is a composite number. So 15 is a composite number because 15 is having more than 2 factors. 15 is divisible by 1, 15 is divisible by 3, 15 is divisible by 5. Okay. And let's say your P is 3. 3 is a prime number because 3 is having only 2 factors. Okay. So if you divide 15 by 3, you will be getting 5 in the result, and 5 is what kind of number? Prime number. Hence, we found one such case that is justifying the statement 2. Hence, it is also correct. Done. Let's talk about statement 3. Let's talk about statement 3. Statement 3, P plus Q can be prime. P plus Q can be prime. So we have to assume values in such a way that sum must equals to prime. So let's say P is 2 and Q was a composite number. Q is 9. P is 2, Q is 9. P2 is a prime, Q9 is a composite number. Now 2 plus 9 comes out to be equal to 11, and 11 is what kind of number? Prime number. Hence statement 3 is also correct because we got one such condition that is justifying the statement number 3. So all the given statements are correct. Hence the right answer is option D. Okay. So class, please note it down. Okay, I hope done. Let's move on to the next case. Now, in this question, examiner says, how many triplets x, y, z satisfy the equation x plus y plus z equal to 6, where x, y, z are natural number? So, see, I have to assume a natural value for x, a natural value for y, a natural value for z, such that the sum of these three natural values is equals to 6. Okay, so what are natural values or what are natural numbers? Numbers that starts from 1, or in other words we can say that all counting numbers that starts from 1 and goes till infinity. So the smallest value of x can be 1. So assume x is 1, y is 1. To make x plus y plus z to be 6, z has to be 4. So this is first such triplet in which sum is 6. X is 1, y is 1, z is 4. So 1 plus 4 is 6. Okay. Now x is 1, y is 2, then z will automatically become 3. This is second triplet. 1 plus 2 plus 3 is 6. Now 1 plus 3 plus 2, x is 1, y is 3, z is 2. This is third triplet. Then 1 plus 4 plus 1, 1 plus 4 is 5, plus 1 is 6. Then can we do 1 plus 5? No. If you do 1 plus 5, then z has to be 0 here. And it is given to us that x, y, z are natural number. And we know that natural number starts from 1. So the smallest value that z can take is 1 only. Hence 0 wala case is discarded. Now, next. Let's assume x is 2, y is 1, then z will automatically become 3. X is 2, y is 2, z will automatically become 2. X is 2, y is 3, z is 1. So 2 plus 3 plus 1 is 6. 2 plus 2 plus 2 is 6. 2 plus 1 plus 3 is 6. So all these triplets are justifying my given expression. So all these are considerable. What else? What else? Or how many other triplets are there? See, 2 plus 3. Now we can go like this. Let's say x is 2, y is 4. Then z has to be 0 to get 6 finally. But z cannot be equal to 0 as z is a natural number. So what next? See, x can be 3, y can be 1, z can be 2. 3 plus 1 plus 2 is 6. X can be 3, y can be 2, z can be 1. Okay, see. Now x can be 3, y cannot be 3. Why? If you consider y to be 3, then z has to be 0 to get 6 finally. Hence this case is discarded. Next, what if x equal to 4? If x equal to 4, then y can be 1 and z can be 1. 4 plus 1 is what? 6. Now, can x be equal to, sorry, if x is 4, then can y be equal to 2? No. If we consider x to be 4, y to be 2, then 4 plus 2 plus 0 will make 6. And I know z is a natural number, so value of z cannot be 0. So this case is not considerable. Now next, can x be 5? If x is 5, then y has to be 1. And if y is 1, then z has to be 0 to make 6 finally. But again, this case is discarded. Why? Because the smallest value that z can take is 1. So in this way, I can see I got only how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Only 10 such triplets that are justifying all the given condition. Hence, option D is the right choice. Okay, kindly note it down. Done. Okay. Now there is one more way of dealing with this question, and that way has to do something with permutation and combination. So you can write down this shortcut directly. The shortcut is, if there are an identical, if there are an identical objects, there are an identical objects, and we have to distribute them in R groups. We have to distribute them in R group such that every group must have at least one object. Every group must have at least one object. Done. So this is a shortcut from permutation combination to deal with this kind of equation when all the variable contained in the equations are natural, right? Every group must have at least one article, meaningly the minimum value that every variable can take is 1. Okay, so if this is there, then the number of ways are n-1 C r-1. So in this case your n is what? 6. So 6 minus 1 C. In this case your r is what? 1 x, y and z. The count of x, y and z is your r. R is 3 minus 1, which comes out to be equal to 5C2. Now if you have an idea of how to solve this 5C2, see, 5C2 is 5 factorial upon 5 minus 2 factorial into 2 factorial. If you solve this expression again, then finally you will get 10 here. Hence the answer of this question is option D. So there are two ways of dealing with this problem. I hope guys you have understood it. So this is it for the video. We'll meet you in the next video. Till then, please take care and bye bye.